Hello guys, so welcome to our third lesson of VHDL, and I'm gonna build upon our first two lessons, and I'm gonna create a more complex hierarchical or structural, design, which you can see here on the screen, which is basically three NAND gates. Okay, I mean, yes, of course, that design can be built easily just in three lines, A and B, okay, or N equal to A and B, then M equal to C and D, then Y equal to C and M. I know that, but just this is just a tutorial to build, a structural model. Again, if you imagine this AND gate, a design that you created before, big design, hundreds of lines of codes. Okay, so you just need here in that design to to replicate this design three times. So no need to write, or copy and paste or something. So that's the idea of having, packages. Okay, so we we learned it in our second lesson how to create package. Okay, out of some designs that you already created. And we did this for the AND gate. That's why in this model here, or this new design, we have three AND gates because we already built that in our first lesson, the AND gate. Okay, so let's do that. I didn't do that. I will do that with you now from scratch, we can say. Okay, but I will build up upon the idea that we already have the AND gate and its package. So the idea now is to create this new design. Okay. So which I will name new design. Okay. So I have here a template for it, or a draft for it. Let's locate it somehow here. Yes, this guy. Okay. So let's open it. So this is just a template. This is not the correct design. This is not this. Okay. So what I'm gonna do now is that I wanna modify the design, modify this file. I will not write anything from scratch. I will just modify this code to represent that new design here. Okay. So let's give it a name. Let's give it, for example, some name like a new design. So let's call this new design. Let's check here, new design, and be sure you name the entity and its end by the same stuff. So here, new design. Okay. What are the inputs of this new design? And we put the inputs in the entity and also the outputs. We have here four inputs. We have A, B, C, D. Of course, each day is case insensitive. So you don't need to make them A capital, B capital. And then the output is called Y. Here is the output. Okay, how about this N and M? N and M are just internal wires, internal designs. I'm sorry, internal wires or internal signals. Okay, and as you know here, or as you see here, they are not input or output. They are both, because N, for example, is an output of that gate and input to that gate. Okay, and M is the same also. It's output of that gate and input to that gate. That's why we are not including them in the entity. The entity is is a part of your code in which you define the inputs of the whole design and the output of the whole design. Where is the whole design here? Here is the whole design, which is encircled with this box here. Okay, good. Let's now do the structure. So the structure needs to define which kind of architecture we are implementing now. We are implementing the architecture of this new design, which we defined here. Okay, let's give it a name here. You can name it whatever. You can name it, Jack. You can name it whatever you want. Okay, so it's a common practice when you build a structure model like this. You call it a structure. So let's call it structure, because it's built out of something else. Okay, and don't forget to We change also the name here, structure. Okay. Good. And now it's time to define the signals. So we define the signals inside the structures because basically, I'm sorry, inside the architecture. Basically, this is the architecture, this box here. And the signals are inside this architecture. So we define the signals between the definition and the word begin, the keyword begin. So we have here two signals. One is called N and the other is called M. Okay, that's good. Then we start the building by the word, begin here, this keyword. Okay, here we should have three AND gates. And remember, we already have an AND gate from our last video. Okay, and we have its package. We have created a package for it. So we are just in, so we first include this package here in these two lines and the gate package. Then we instantiate. How many AND gates we need? We need three AND gates. So you must create or instantiate three instances of that AND gate. One of them will have A and B as inputs. So for example, and of course they should have different names. This is wrong now. I just copied and pasted. Okay. So these names should be changed. So let's call them AND gate 1 or 1, 2, 3. These are labels. Okay. You can name them whatever. But I like, for example, to name them something meaningful. Okay. Then you write here the entity of the package. So if we go to the package of the AND gate, I hope I am lucky enough to find it. Here it is. Look here, the component is called the AND gate, and this is basically the name of the entity of the AND gate design. If we go to the AND gate design, and here it is, look, this is the name of the entity. So in the package, we take that exactly here, and we should, have the same entity name and the same inputs and the same output in the package. Then in the design, the new design now, our new design, it's a weird name, but it's a new design. We should, follow the same entity name here. Otherwise, the compiler will not find this package. It will give you an error. Then we make port map. Okay, this is a keyword, which means, okay, map what's coming next to what you have in the package. So let's go to the package here. The package here has two inputs and an output. So the order here is important. Okay. So the inputs should be mentioned first, then the output. The first AND gate has A and B as input and N as output. The second AND gate, which we call 2, has C and D as input, C and D as input, and M as outputs. Good. Now the third AND gate has N and M as inputs, N and M as inputs, and Y as output, which is basically the same as the output of the whole structure. And that's it. Then we compile. We hope we have no problems. We save first again. We didn't save. We should save. We compile. And looks like we are successful. And of course, this is a problem if you're having everything in one project. As you see, guys, here, I created in all my designs the same project. So it will take some, maybe half a minute or something to combine all of them. And this is not, you can just ignore this. Just look at the final. So yeah, 0 failed with no errors. Okay, so we're gonna go now to the to make a test bench for that design here. Again, we're gonna use a test bench file that we already have. We don't need to create something from scratch, and we're gonna use this test bench to to do our simulation. Okay, how are we gonna create the test bench? So I'm gonna use the test bench that I already created for the AND gate from the last lecture. or last two lessons of each there. Okay, so I'm gonna create a new one and copy and paste from the ones that we already created into in that one. So let's have here new design. So add to project, new file, and let's call it new design. You can name it whatever, but let's call it with new design here. And I like to name same name of the design plus underscore test bench. Okay. If we open it, if we go to it and open, it's just empty. Now we go to the test bench that we already have of the AND gate and copy it and paste it here. Then we should change many things here, especially the naming. Okay. So first of all, any test bench has two components. I will give you a video, a complete video to highlighting what's exactly these parts. Okay, but let's just use it as a template now, without understanding much of understanding of the part of this entity or this test bench. So first of all, any test bench is two parts: an entity and architecture, just like the design. Any design, if we look at the AND gate, for example, here, I'm sorry, the new design that we have, here is an entity and architecture. Any design we will create has entity and architecture. In the entity, we define the inputs and the outputs. But since the test bench is not a new design, okay, so there is no new inputs or new outputs. That's why its entity is just empty. Okay, it has nothing there. So what kind of name we should give to the entity? I like to give it the same name of the design, which is in our case new design here, and then underscore test bench. So I'm gonna change this to new design underscore test bench. Then the second part, which is the architecture, in which we should also give it a name. So this is the name of the architecture now. And look, it is similar to the name of the entity, but instead of writing test bench, I'm writing TB. Oh, just naming. And whenever you choose here, you should write it again here. Copy and paste is the best way. And don't forget the semicolon. This architecture of this design, not the AND gate. So we should change this as well. And save. Then, since this is not a new design, okay, what we are doing is basically we instantiate basically. We instantiate from our new design here, okay, and an instance, and we apply signals to it. So in that part, which is component, just like defining the packages, okay, we will instantiate our design. Where is our design? Here is our design. So I'm gonna take this new design here. First, take the entity. So it takes the body of the entity and just paste it here in that location exactly. Okay. Then take the name and put it here. And that's it. So here I am saying, please create a component for me, an instance for me from this design called the new design, which has these inputs and that out. That's what I'm saying exactly. So the test bench in that sense is just a design also, but this design has, one instantiation of one component that you create for your design, which is this one. It's really, not that intuitive, but I'm gonna explain this in another video. That's not our problem now. Okay. Then we need to, the rule of the test bench is to create signals by which we will test our design. Okay, good. So how many inputs we have here? We have 4 inputs. So we must create 4 signals. Each one will be connected to one of the inputs. Okay, so I'm gonna create 4 inputs here, 4 signals. I'm sorry, 4 signals, not 4 inputs. I will name the first one AN, and I will connect it to AN. And this is also a name. You don't have to call it AN. That's a naming. You can call it whatever. Okay, bn, then cn, then dn. How many outputs? We have one output called y. Then I will define an output called what I can call it again whatever, but I will call it here y out. So you guys will know exactly what you are doing. You're not confused with other signals together. So good naming is very important. Of course, this is a small design. Maybe it's not that clear how important is the naming, but for bigger designs, you should have clear or meaningful names. Okay. Then again, we make this instantiation. This is not also our topic now. I will do that in another video. Okay, but this is basically the instantiation. Here you define the component, and here you instantiate this component. And just like our design here, any instantiation needs a name, needs a label. And this is the label here, DUT. And DUT means device under test, and you can call it whatever, Jack. Okay, doesn't have to be DUT, but it's a good name to give it DUT because this is what's under test now, the design under test. Okay. Okay. Our device that is under test is new design, so we should change the name here. Remember, we are using some templates that we have before, some test images that we have before. We are not creating it from scratch. Okay, new design has 4 inputs. So here we will do the mapping. So if we write A input in the beginning, this will be connected to A. B input, the second will be connected to B. Then we need C input and D input. So we just copy and paste. So C will connect it to C input will connect it to C, D input will be connected to D, then Y will be connected to Y. Can we, for example, connect A input to B input to B? Yes. These are just naming. You don't have to call it AN. You can call it what you can call it BN and connect it to AN, and you can call this AN and connect it to BN. No problem at all. But you should follow exactly what you are doing, not to be confused while debugging. Okay. Now these are the tests, the kind of tests that we're gonna do. Okay. So if you have 2 inputs, A and B, for example, you need four combinations, 0, 0, 0, 1, 1, 0, 1, 1. Here in our example, we have 4 inputs, so we need 16 inputs, or 16 combinations. Okay, so that's what I'm gonna do right now. So I'm gonna create, this is the first one, 0, 0, 0, 0, and remember to change the names here to CN, DN, then copy and paste, and then we will change later, the combination. So, oops, I copied instead of pasting. So copy again, paste. Okay. These are for, I'm sorry, yeah. These are for, how many? This is 1 combination, 2 combination, 3, 4 combinations. So we need 16. So we're gonna just copy this 4 times and paste it 4 times. 3, 4, 5. I'm sorry, just 4. Oops. And 1, 2, 3, 4. Okay. These are 16 combinations, but we should of course modify them. So 0, 0, 0, 1. Look, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, then we make like this. This is just a comment here. And then A, guys, A, which is the most significant bit, will become 1 in the last 8 combinations. That's what I'm gonna do right now. This is 1, 2, 3, 4, 5, 6, 7, 8. We are right. Okay, I'm gonna take this and make it each 4. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. B will change every 4 combinations. So at the beginning it was zeros, then it will be ones, 1, 1, 1, 1. Then it will be 0, then 1 again. Okay. Now C will change every 2 combinations. So 0, 0, then this will be 1, and this will be 1. Then 0, 0 again, then 1, 1. Then 0, 0 again, then 1, 1. Then 0, 0 again, then 1, 1. Looks like we have some error with B because B 1, 1, 1. Yeah. Oops. Yeah. This should be changed to 1. Okay. And C will change every other combination. So 0, D, I'm sorry, D. Here is 0, here 1. Then 1 here. 0, then 1. Then 1. 1. 1. 1. And 1. And just a check here, the 16 combination should be all ones. And that's it. Now we have 16 combinations, guys. All possible combinations for A, B, C, D. Okay. Now we save that guy and compile it. And we may have error, then we can fix them together. No problem. Looks like we have no errors. That's very nice. Okay, now we are ready to start the simulation. Start. You open work. And we look for new design underscore test bench. New design. Yes, this is new design underscore test bench. And it's opening right now. It's open now. Okay. And here we have our inputs and outputs. Okay. And here is that one. We're going to make it only 1. Then we run. We zoom out a little bit. Okay, there is a 16th. Remember, we should have only 16 combinations. So this will be the last bits. As you see here, 4 ones. 4 ones. And let's go back to our design now, not to forget about it. This is the design. This is what is bit. So y is equal to n and m, right? What is n in A and B? What is m, C and D? So basically y is A and B and C and D. So y should be 0 only if all the 4 inputs are ones, which is the last our last input. So let's check that. Here, all of them are zeros, so we have 0. Look. 0, 0, 0, 1, we have still 0. 0, 0, 1, 0, still 0. 0, 0, 1, 1, still 0. 0, 1, 0, 0, still 0, and so on. All combinations y 0, except the last one, which is a 16th bit from 0 to 15 here. Look, guys, 1, 1, 1, 1, we have at least 1. Look at the signal of the output. So if we change its color here, where we change the color, I forgot. Format or properties, yes. Properties, color. Let's make it with yellow, for example. Okay. Look, it's all 0, all 0. Just concentrate with that number here. It will be all 0. Whenever I move until we reach the final combination, 1, 1, 1, 1, and it will be 1 at that time. Okay, guys, I hope this helps you in your design. Okay, your assignment, which is implementing XOR using NAND gates. Okay, it should be very similar to what I have done here. Also, for the test bench, again, to make sure that you understand correctly, for the test bench, we will not have the 16 combination. Remember, our design is XOR, two input XOR. So you have only four combinations. I did here 16 because our design, requires 16 combination to be tested well. Okay, so thank you very much and see you in the next videos. Bye bye.